Let's start by exploring the fundamental building blocks of a computer system. At the heart of every computer are several key units: the input unit, output unit, memory unit, arithmetic and logic unit, ALU, and the control unit. The input unit is responsible for converting the data you enter into a format the computer can understand, specifically binary code made up of zeros and ones. Output unit, on the other hand, takes processed data and translates it back into a form you can easily interpret, like text on a screen or a printed page. The memory unit stores data and instructions, while the ALU performs all arithmetic and logical operations. Finally, the control unit acts as the central nervous system, coordinating all activities within the computer. Together, these units ensure smooth data flow from input to processing, storage, and output, forming the backbone of every computing device. Now let's dive into how computers actually process information. The only language a computer truly understands is binary, strings of zeros and ones. Every piece of data, whether it's a letter, number, or image, is ultimately converted into this binary format. The smallest unit of data is the bit, which can be either a 0 or a 1. 4 bits make a nibble and 8 bits make a byte. Larger units like kilobytes, megabytes, and even yottabytes are built from these basics. Understanding these units helps us grasp how computers store and manipulate vast amounts of information. For example, a single nibble is 4 bits while a byte is 8 bits. This binary foundation is what enables computers to perform complex calculations, store multimedia, and run sophisticated programs, all by manipulating simple on-off signals. Let's move on to logic gates, the electronic circuits that make decisions inside a computer. Logic gates operate on one or more input signals to produce a specific output, using binary logic. The main types include AND, OR, NOT, NAND, NOR, and XOR gates. For example, an AND gate outputs a 1 only if all its inputs are 1, while an OR gate outputs a 1 if any input is 1. The NOT gate, also called an inverter, simply reverses its input. Universal gates like NAND and NOR can be used to create any other type of logic gate, making them essential for building complex circuits. These gates are the foundation of all digital electronics, enabling computers to perform calculations, make decisions, and execute instructions. By combining these gates in various ways, computers can process everything from simple arithmetic to complex algorithms. Finally, let's talk about storage, the component that allows computers to retain information. There are two main types of memory: primary like RAM and secondary like hard drives and SSDs. Primary memory is fast and directly accessible by the CPU, but it's volatile, meaning data is lost when the power is off. Secondary memory, such as hard drives, is non-volatile and retains data even when the computer is shut down. Registers, a type of internal storage, provide quick access to data for the CPU during processing. There are also different types of ROMs like PROM and EPROM, which store data permanently. Technologies like RAID use multiple disks to ensure data reliability and speed. Understanding how data is stored and retrieved helps us appreciate the complexity and reliability of modern computers, ensuring our files, programs, and memories are safe and accessible.